Once you've collected the data set, the next step is to describe the data set. And what does it mean to describe a data set? When you see the words describing data, you might think of talking about the data, but describing data doesn't actually mean talking about the data. It means presenting the data. And it actually means presenting the data in a way that's summarized and easier to understand. It means presenting a boiled down version of the data. It's easier for you to make sense out of, and it's easier for other people to make sense out of. Let's look at an example of describing a set of data. Let's say that I wanted to collect data from 10 college students who were taking classes during the day, and from 10 college students who were taking classes at night. So these are the students that I'm collecting data from. And also imagine that I'm asking each of these students how many hours they're working per week. And imagine that these are their answers. So I've asked 10 college students who take classes during the day how many hours they're working per week, and I got these 10 answers. And I asked these 10 students who are taking classes at night how many hours they're working per week, and I got these 10 answers. Now, by just looking at these numbers, I can get a little bit of a sense of what the data seems to be showing. It looks like the 10 students who are it looks like the 10 students who are taking classes during the day are working fewer hours per week. And it looks like the 10 students who are taking classes at night are working more hours per week, because over here most of the numbers are in the 20s. Well, actually all of the numbers are in the 10s or 20s. And over here all the numbers are in most of the numbers are in the 30s and 40s, and we have 120 right here. But if I wanted to present this data to someone so that they could easily understand what this data is showing, I wouldn't want to just give them the 20 numbers. I would want to give them a summarized version of the data set. How could I summarize this data set so that it's easier to understand, and so that it won't take as much effort for someone to understand what my data is showing? One thing I could do is calculate the average of these 10 students, and also calculate the average of these 10 students. Then the person who is looking at my data can just look at the average of this group of people and look at the average of this group of people and look at the difference between the two averages. So let's actually see what the averages come out to. I can get my calculator. To get the average of these 10 students, I have to add the numbers and divide the total by 10, since there's 10 people. So when I add and divide by 10 to get the average, it comes out to 17.6. And I can do the same thing over here. I can get the average of those 10 students. I just add the 10 numbers and divide the total by 10. Over here it comes out to 36.5. So if I show these two averages to someone so that they can see that this average is lower and this average is higher, I've described my data set to a person because I've given them a summarized version of the data set that allows them to see what my data set is showing. Now, what's another option to describe this data set besides just calculating these two averages? What's another way to present the data set to someone? Well, I could also show a graph like this. I could create a bar graph. Maybe it goes up by 5, 10, 15, and 20. So then this bar would go up to 17.6, which is right here, or about right there. And this other bar for the night students would go up higher. So now, what this graph is doing is describing my data set. This graph is describing what message my data is showing. This graph is showing that the 10 night students are working more hours than the 10 day students. And if I look at this graph, then this graph is describing my data set to me. And if I show this graph to someone else, then this graph is describing my data set to that other person. So whenever you summarize your data set and present it in a summarized form, such as by calculating averages, like we did here, or by showing a graph, you're describing your data set. That's the process of describing data. The process of describing data is summarizing the data and then presenting it in a summarized form. Now, what does interpreting data mean? Interpreting data is when you actually make a conclusion about what the data set is showing to be true. When you make a conclusion about what the data set is showing about the world that we live in, you're interpreting the data set. And when you interpret the data set in a data collection project, you're typically trying to make a conclusion that extends beyond the participants that are in your study. For example, once I collect data from these 10 day students and collect data from these 10 night students, I'm not going to want to just make a conclusion about these 10 students here and these 10 students over here. I'm going to want to make a conclusion about day students in general and night students in general. Let's say that there's I'm just going to make up some numbers. Maybe there's about 12 million day students in the US and 7 million night students in the US. The goal of my data collection project might be to actually make a conclusion about whether the 12 million day students are working fewer hours and whether the 7 million night students are working more hours. So I could be actually trying to make a conclusion about a big category of people here and a big category of people over here based on the participants that I've selected. And if I actually make a conclusion that all of the day students in the US are working fewer hours on average and all of the night students in the US over here are working more hours on average. I've interpreted my data set once I come to that conclusion. I've interpreted my data set because I've taken the data that I've collected from these people, and I've reached a conclusion about a bigger category of people that goes beyond just the people that I've selected to collect data from. And since people who collect data try to make conclusions, or since they do make conclusions that go beyond the specific people that they've selected to collect data from, the conclusions that they make actually aren't proven conclusions. Meaning, if you interpret your data and you make a conclusion about a big category of people based on a small group of volunteers, then there's always a chance that you'll make a wrong conclusion. But the good news is, when data collection is done properly, and when the data is interpreted properly, meaning when people make the conclusions properly, then most of the time correct conclusions will be made, and incorrect conclusions will be made less often. But whenever you make a conclusion about a bigger category of people, then whenever you make a conclusion that goes beyond your volunteers and is about a big category of people, there's always a risk of making a wrong conclusion. So nothing is proven.